All right, so now the next step in our process now is to include the y-axis. So we did the x in the previous video. Now we're going to look at the y. So we have these 3 points on here, and this is actually our center of mass for this problem. So the first one is a mass of 2, and we're at the point -2.8. The second is a mass of 3, and we're at the point 1.2. And then the third is a mass of 4, and we're at the point 7.5. So the way we look at this is we do exactly the same thing, and you just focus on just the x's. So you can see I brought down -2, I brought down 1, and I brought down 7. And so we would end up with these 3 points basically. So how you want to look at it is this. Let me open the Desmos and we'll take a look at it. So if you notice our points here, what I'm going to do is play with the y. And look at the y. Do you see the x's changing at all? None of the x's changes. So if you move the y, the center of mass for the x doesn't change because it's only based on the x coordinates. So the way you can think about it is I'm going to take all my y's and move them down to 2. So now they're all lined up and they just become this, our line that we had before. And then we can calculate the mass just like before. So it would be, this is a mass of 2, so it'd be 2 times -2. This is a mass of 3, so it'll be 3 times 1. And this is a mass of 4, so it's going to be 4 times 7. And we add all those up and divide it by the total of the masses, which is 9. And that would give us our 3. And, let me reset this. If I move the x's, you can see that the y's don't change. So if I move all my x's to 7, now they're all perfectly lined up here. We can do exactly what we did before, but now for the y-axis that we're focusing on. So we have 2, 5, and 8. Those are our locations. And the mass at 2 would be 3. The mass at 5 would be 4. And then the mass at 8 is 2. And so it'll be 2 times 8, 4 times 5, 3 times 2. We add those up, divide it by 9. So that's what we're doing here. The x-coordinate is just going to be taking all of our moments for the y-axis. So those are the ones around the y-axis. And that's our x's. So it gets confusing there. So the my is this. We have to write the notation, and the mx is this. But it really is our x's. We add up the x's. The y's, we add up the y's. And all it is we're taking the mass times the x-coordinate. Mass times x-coordinate. Mass times x-coordinate. We add them up. That's our numerator. We divide it by the number, the total sum of all the masses, just like before. So I've already got it all lined up for us. So just like I said before, if we move all of these points down and line them up, they would look like this. And so that would give us our line just like this. So if we want to find our hex hat, what we're going to do is take our m1 x1, add it to our m2 x2, and add it to our m3 x3, and then divide it by the sum of all of those masses together. So the first one was 2 with an x-coordinate of -2. The second one is 3 with an x-coordinate of 1. And the third is 4 with an x-coordinate of 7. And then we take our masses. So mass of 2, mass of 3, mass of 4. Again, that's the mass. It's 2, 3, and 4. And so if we multiply all this out and then divide, you're going to see that we end up with 3. So this is 28, right? And then -4, so that would be -4 plus 3 is -1, so it's 27 divided by 9, which is 3. That's our x location. Now, to find the y, we do the same exact thing. So again, you can think about just taking all of these and giving them exactly the same x-coordinate so that they line up perfectly, and we can find what they become. So to find our y hat, our y bar, I keep saying hat, we're going to go m1 times the y-coordinate plus m, it doesn't even matter the order, so we already have it m1, m3, m2. We're just going to go in order to keep it easy. So 2 times 8, 4 times 5, 3 times 2. And again, we already know the sum of the denominator is 9 because it's 2, 4, and 5. Masses don't change just by moving them around. They're still the same mass, just different location. And so that you'll see becomes 4.667, so 4 2/3. So if we multiply these out, we get 16 plus 20, which is 36, which is 42. And then this would become 36, which is 4 and 2/3, which is our location there. So now putting that together, that means our x coordinate, we're just going to get x bar, y bar for our answer, which would be 3, 4 and 2/3. And that is our center of mass right there. So that's all you have to do to calculate it. It's just take the mass, multiply it by the y, mass multiply the y, mass multiply the y. That's your numerator, divided by the sum of the masses. That's your y coordinate. To find the x bar, it's mass times x, mass times x, mass times x, divided by the total sum of all the masses. And that's your x coordinate. Put them together, that's your answer. So it's not too bad, right? So you can play with that calculator and see how it moves things around. The link is given, and so you can see by doing the x, the y is not affected at all, the y's location. We can move the x around, right? You can even increase the mass, and watch, what I like doing is showing you that if you increase the mass, you're going to pull the center of mass closer to that point because it's going to be heavier. See? It's pulling it straight to it because it's heavier, so it's going to pull the center of mass to it. All right, but that's our formula. And then all this is lining up to is our next video, where we're going to actually give us some region, and we're going to find the center of mass using this basic principle. Our x's are affected by the x's, the y's are affected by the y's.